In this video, I'd like to talk about the different strategies we can use when applying the elimination method. So remember, with the elimination method, we usually line up our linear equations in this standard form. We line it up column by column. So notice the x values line up and the y values line up. And to solve this, we'll have sometimes multiple different choices, but the general idea is that you either want the coefficients on x to be the same or opposites, or you want the same to be true for y. You want their coefficients to be either the same or the opposite. Now, if they're the same, like in the case of x, we could, in theory, subtract the bottom equation from the top, and that would eliminate the x values. But if we want to focus on the y values, we could, in theory, add the bottom equation to the top, since their coefficients are opposite and positive 5 plus negative 5, the y values would cancel out there. So there's often different approaches that you can take, and sometimes the coefficients are not even the same. For instance, we might have a case where, let's say, for example, we had 4x minus y equals 8, and we have 2x plus 2y equals 7. So in this case, notice that neither the x coefficients or the y coefficients are the same or the opposites. So in this case, you'd have to change one of the equations. Like maybe we want to make the y coefficients the opposite, so I could multiply this entire equation by 2. And that would transform it into 8x minus 2y equals 16. And now, since the coefficients on y are the opposite, now I can just add the bottom equation to the top, which would eliminate the y variables. And alternatively, we could have taken a different approach and tried to make the coefficients on x the same. So for instance, we could have taken the bottom equation and multiplied that by 2, and that would make the coefficient on x 4x, and then we could subtract the bottom equation from the top. So sometimes you have to change one of the equations so that you can actually apply this elimination method. Now for this example though, we don't have to do that. So we just have to decide which of the following strategies should we use to eliminate one of the variables here. So our first choice, multiply the top equation by 7, then subtract the bottom equation from the top. Well, if we multiply the top equation by 7, that would make the numbers the same. But we're not interested in eliminating the numbers. We're interested in eliminating one of the variables so that we can transform it to an equation where you just have one variable, which is straightforward to solve. So multiplying the top equation by 7 wouldn't help us, since it would actually make all of our coefficients different rather than the same or the opposite. So this is definitely not true. Now B, we could subtract the bottom equation from the top. Now we mentioned that if we do that, notice that the x values would be eliminated there. And you just get 5y minus negative 5y, which is 10y, and 1 minus 7, which is negative 6. And from there, you can solve for y. So it looks like choice letter B would work. So that's true. But we can also add the equations, since I mentioned earlier that if we add these, the y values would eliminate each other. We'd have 5y minus 5y, which is 0y. And you just end up with 12x equals 8, and again, you can solve for x there. So in this case, choice B and C were the correct answer. So let's move on, and we'll practice several of these examples. So we need a strategy to eliminate one of the variables. And again, we're just going to go through each of these choices because we need to choose all the answers that apply. So it could be multiple. Now, the first one says multiply the top equation by 5 and then add them. So if we multiplied everything by 5 here, we have 5x minus 10y equals 55. And from below, we have 5x plus 3y equals minus 11. Now, if we add these, the problem is that it wouldn't eliminate a variable. We'd end up with 10x rather than eliminating the x's. Because we did make the coefficient on x the same, but adding is the wrong operation here. What we really should do is subtract. So choice A is not correct there. And if we look at B and just add the equations, Since the coefficients on x and y are not the same and they're not the opposite, this would not eliminate one of the variables. Now, it would make the numbers on the right-hand side equal to 0, but again, eliminating the numbers is not our concern. We want to get rid of one of the variables. So this isn't true, and so by process of elimination, we know that this has to be the answer, but let's just make sense of that. We're going to multiply the top equation by -5 and then add. So if we multiply this by -5, it would essentially just flip all these signs, because remember, this is from when we multiplied by 5. So -5 times x would be -5x. -5 times -2y would be +10y. And we'd end up with a -55. And now if we add, notice that the coefficients on x are the opposite. And so when we add, we end up with 0x. And we get 10y plus 3y, which would be 13y. And -55 plus -11 would be -66. And this is solvable, since we have an equation with just the variable y, and we could, in theory, just divide by 13 to figure out what y is equal to. So choice C here would be the correct answer. So we have the same type of problem, and we're just going to go through each of these answer choices. So notice, looking at the problem, that the coefficients on x and y are not the same, and they're not opposites. So we're going to have to do some multiplication to transform one of the equations so that we can use elimination. So in choice A here, if we multiply the bottom equation by 6 and then subtract it from the top one. So let's try that. Multiplying this whole thing by 6, so you get 42x minus 6y equals -12. And I'll rewrite the top one. And notice that the coefficients on y are now the opposite. And so if we subtract like they advise, what happens is you have 6y minus -6y, which is the same as adding 6y. So in this case, you don't eliminate y. You end up with even more y's than before. So the correct operation would have been addition here. So if this said addition, then this would be true. But since we're subtracting, we know that this is false. Now B, if we multiply the top equation by 7 and then we add, that might work for us. So let's do that over here. So this was for A. So for B, if we multiply this by 7, we have -7x plus 42y equals 8. And the bottom equation, 7x minus y equals -2. And now we're adding, and this would actually work because the coefficients on x are the opposite. So when we add, we get 0x. So these are eliminated, and 42 minus y, that's 41y. 8 plus -2 would be 6. And again, you can solve for y, and once you find y, you can plug it back into either equation to find the x value. So this one worked. But for C, if we just add the equations, like I mentioned in the beginning, the coefficients on x and y are not the same, and they're not opposites. So just adding the equations is not going to eliminate a variable. So for this problem, just choice B is the correct answer.